Today is July 15th. Now it is past 3 p.m. in India and it's past 10:30 a.m. in England. It's time for the webinar. On behalf of the organizer, Department of Physics, Prabhu Jagatbandhu College, Kolkata, I wish a good morning to our honorable speaker, Dr. Amit K. Chattopadhyay, and participants from England. And a very good afternoon to our honorable principal, Dr. Subroto Kumar Rai, my institutional colleagues, and teacher participants who registered with us from various schools, colleges, universities, and research institutes of not only our state, but also from many other states of our country. And last but not the least, good afternoon, my dear student participants. I feel proud to address such an assembly. At present, we are in the midst of a pandemic, surrounded by life-threatening terror and uncertainties of many kinds. I check Worldometer often. It says, till date, more than 134 lakhs of people across the world have been infected by COVID-19, and nearly 5.8 lakhs have died. In most recent past, 10 years ago, the swine flu pandemic killed little more than 2,700 of people in India, while the number of confirmed deaths this time so far in India is nearly 10 times of that. And we all know here in India, worst is yet to come. The biggest factor behind so many affected people is our lack of knowledge about the virus itself and thus how to treat it. No drug has been proven to be effective totally till now, though we have hopes that a commercial vaccine will be ready soon. Doctors and researchers all over the world are working hard. We who are not in the frontline research are very much eager to know what is going on, what are the directions followed by them. Today, we assembled here to listen from one of such researchers, Dr. Chattopadhyay, about a particular possibility of the solution, which is herd immunity. Via vaccination, it contributed to the eradication of smallpox in 1977, so it may work now also. Another possible solution is containment. That is why we are presently under lockdown. We all muse how effective the lockdown is. Today, it will be clear. We will understand about the impact of lockdown as a function of lockdown imposition and withdrawal dates. So let's be attentive, be receptive, and enjoy the webinar. Now I invite Dr. Kishore Mukhopadhyay as the anchor for this webinar henceforth. Over to Dr. Mukhopadhyay.
Thank you, Dr. Dolon Champa Saha. And welcome to the international webinar on mathematical modeling of COVID-19, propagation kinetics, herd immunity to containment. I welcome you all. Now I request our respected principal, Dr. Subroto Kumar Ray, for his welcome address. Please, sir, please start your welcome address.
Am I audible?
Yes, sir.
Yeah,
Now? Okay.
audible.
So today we have assembled here to participate in the webinar organized by the Department of Physics, Prabhu Jagatbandhu College, West Bengal, India. The topic or the theme of this webinar is mathematical modeling of COVID-19, propagation kinetics, herd immunity to containment. So I think we are very lucky and very much interested also to listen from the main speaker and of course the guest of honor, Dr. Amit Kumar Chattopadhyay. He is presently at Aston University, Birmingham, UK. The topic is very much relevant today because of the fact that not only India but also the whole world actually now under threat due to the pandemic COVID-19. So we think that a immediate solution of this problem is a necessary one, that is not only for the developed nations but also for the underdeveloped or developing countries also. This pandemic, COVID-19 pandemic, is a shock to the society. It is very difficult for us to absorb this shock without the proper medicine to be applied for the cure of the disease. To protect the COVID-19, for the eradication of this pandemic, I think the country like India is in very tensed, or you may say in very crisis situation, because of the fact that the lack of awareness of the people. Though we see that not only the developing of the underdeveloped countries but also the developed countries like America, USA, there we also see the shock is very, very high. I mean, the death is very high for this country like the USA. So today we are actually waiting to hear the lecture by Dr. Amit Kumar Chattopadhyay. We are waiting for that. So I will not tell more. Just after this short introduction, I welcome Dr. Chattopadhyay on behalf of our institution, Prabhu Jagat Bandhu College. I welcome all the colleagues, means not only the professors of our college, but also the participants and the professors, researchers, students from other colleges and the universities and the research institutions and schools, okay, etc. All the participants, for all the participants, again I am in the phase of welcoming them. So I welcome all. Again, please sincerely participate in this webinar. Thank you all. Welcome again.
Sir, for your valuable comments and
encouraging words. Now, I request our convener, Professor Pramita Howley, to introduce our speaker. Professor Howley, please.
Thank you, Dr. Kishore Mukhopadhyay. Good afternoon to all. I feel privileged that I will introduce our guest of honor and speaker, Dr. Amit Chattopadhyay, to you all. Dr. Chattopadhyay is a theoretical physicist specializing in multidisciplinary applications of physics and computational mathematics in physics, quantitative biology, material science, and mathematical finance. His research novelty lies in unifying four diverse research areas: quantitative biology, mathematical finance, soft matter physics, and material science, analyzed using mathematical and data modeling. Dr. Chattopadhyay has published more than 70 papers in various leading international journals. Also, he is an editorial board member of the Nature and Frontiers group journals, amongst others. Actually, Dr. Chattopadhyay is from our city. He did his PhD on statistical and field theoretic turbulence modeling from the Indian Association of the Cultivation of Science, Jadavpur, in 2001. He had his first postdoc at the Max Planck Institute for the Physics of Complex Systems in Dresden, Germany. A second one as a Humboldt Fellow at Hans-Meitner Institute in Berlin. He worked as a research associate at the University of Warwick, UK. He was the first Indian maritime at the University of Padua, Italy. He joined his first academic position at the University of Edinburgh in physics that he left to return back to India, where he joined the University of Delhi Department of Physics and Astrophysics. At present, Dr. Amit Chattopadhyay is a reader in mathematics at Aston University, Birmingham, England, UK. He is a senior fellow of Higher Education Academy of Aston University and a fellow of the Institute of Mathematics and Application, UK. Today, he has joined us from Birmingham. We are really honored by your presence, Dr. Chattopadhyay. So now it's time to begin our academic session. May I request Dr. Chattopadhyay for his presentation. Over to Dr. Chattopadhyay.
Okay, right. Should start by sharing the screen now. Could you please confirm if I am being audible, also the screen is visible? So just keep an eye on the chat box. If any of you could just inform, because there had been a glitch, and it's partly usually my fault, not anybody else's. So I just wanted to make sure if we start the presentation that it's being audible and it is okay, fine.
Yes,
Okay, good.
yes,
Thank you.
please.
Okay, so I will start with, which I didn't want to and I didn't hope to, certainly, with a strong word of apology. This is related to the fact that Kishore, who has been the backbone of this particular description, the particular setup, he wanted to set everything by himself, and I believe that I would be able to supervene and try and do an even quote-unquote better job, which exactly turned the other way around. So the YouTube link that was set up, we set it up a couple of days ago, and
Amit, could you please raise your voice slightly?
Sure. Let me see. Yeah.
Yes, yeah.
Better?
Yes. So you can see.
Is it better? Is it better? Can you hear me now?
We can hear you, but not properly. Can you
Okay, let me just
make
take
it
this,
more better?
Let me just take the mic off and see if that makes things
Yeah.
better.
Okay, okay.
Is this better now?
Yes, it's better now.
Okay, perfect. It's even better for me. Thank you, Kishore. So I was just about to say, I mean, it's really the word of apology to start with. You have all been delayed, and it's my fault. It was set up 2 days ago, and not just Kishore, it was held from Dolandi and Pramit, I believe. So the fault related to the crash or the sort of discord that I was having between certain screen reader, OBS, and its costing through YouTube. So there was a discord, so I had to reset it, and in the process, the link broke. So what I have tried to do meanwhile, it's the last thing, the last sort of thought that could be done in this particular circumstance. So I literally shared the link through LinkedIn and some of the WhatsApp friend list and emails, whatever I could do. You should have probably had done the same. And it's really, again, it's very disappointing for me, for Kishore, who put so much of time and effort in this, and basically to disappoint him. Really sorry about this. Shouldn't have happened. And instead of a potential 500 audience, we are just now restricted to the number that we have on the Google Meet. And yeah. So there's not much that I could say, or neither could I do at this particular point in time. I certainly would be particularly careful in the future. Let's now come back to the topic of the talk. Now, we have a raging problem at the moment. The problem, as we all know, and this is nothing that I really have to start out and say something scary about, it is scary, and we are all aware of that. So it's COVID-19. So the name 19, as we all know, starts from the year that it was first detected. Is a very strong word and a dodgy word here. It was first recorded, probably would be the best thing to put it. 2019 December, it was detected, well, certain regions in China, they actually detected a spurious virus that was raging like a wildfire and was not being controlled. So initially, as probably within the limits of decency, I would have to point out to certain chaotic and conflicting information supply from WHO, the World Health Organization. So initially, WHO declined that as a pandemic, and later it was declared as one of the worst forms of pandemics. Not just this, there had been many other discords and statements from WHO that we all have been familiar with by now. So that is an issue, and not something that is of bother for me, but the issue is we have an ongoing serious problem. Some of the countries are sort of now over the board. Some of the countries are coping well and are past their peak. Some countries, certainly India, for example, is not past its peak, and the statistics, as we can show, and I hopefully will be able to convince you from the predictive modeling that we have been doing in this particular regard, is quite scary. So we will come to that. Just a bit about my own background. So my name you have heard. I am in Aston University. This is in the Midlands area in the UK. So Midlands has quite a few vaunted universities in the UK context, and Aston is one of them. I am in the mathematics department, and SARI that you see in front, it stands for Systems Analytics Research Institute. It is a multidisciplinary research institute which combines different research heads. So I am a mathematician. There are certain mathematicians there, some physicists, some computer scientists, some people from biology, some people from optometry. So in real spirit, it is a multidisciplinary department. So what do? We sort of brainstorm and try and collaborate and collate information and basically exchange information between ourselves to try and paraphrase the best possible way to attack a general scientific problem Now, most of these are interdisciplinary problems, so a single person cannot really deal with that. So if it is a biological problem like the one that I'm talking about today, I'm not a biologist, so I cannot go into the biological details, and for that we need a biologist to come up with the biological details, or for that purpose, a medic to give us details about the medical propensities of the problem. If it is related to vaccination, if it is related to therapeutics, we would need people to tell us, the proper medics and the proper medical scientists to tell us and give details about those. An oxymoron to start with, and for this part, I know that I'm talking to a predominantly physics and mathematics audience, but probably there would be a few who are from neither end, so mostly for them. It's an oxymoron to start with, mathematical modeling and then herd immunity, which is a biological context, because we grew up with the idea that mathematics and biology, they don't sit side by side, they don't really see eye to eye. And what I'm trying to do here is a happy marriage in between the two. So basically the point here is this: the biological details, which are replete with information on the phenomenological aspects, and some of them could transmute themselves into some numbers, statistical numbers. How can we make sense of those numbers that are read out of the biology of whatever we are talking about, and try to paraphrase that within a logical contour? So mathematics is that logical contour. And modeling, it can mean many different things. For our purpose, we would be exclusively focusing on what we call predictive probabilistic modeling. So probabilistic modeling effectively implies that I'm trying to look at the past, and from that information, I will try to read the future. That's exactly what we will try to do here. Now, a bit of an epilogue here. So what sort of modeling, and I will take the example of something that we are all familiar with from a very non-mathematical perspective. So when we are jabbing on our mobile phones these days, so if I'm typing a text or if I'm writing an email, we get Google prompts. So the Google sort of reads my mind and preempts what is the phrase, what is the description that I would probably be putting in. Or for that purpose, it sort of thought reads my intentions in buying and selling stuff, and it comes up with very colorful and very often the right choice. How does it happen? So some sort of a preemptive, predictive mechanism is lying at the heart of this. What we have done here is to hijack one of those amongst many different options, and we have implemented it. So we have sort of joked it together with the fairness of mathematics, and out come certain predictive layers, some predictive numbers that will tell us how possibly to read the prognosis and the diagnostics of the COVID-19 situation that we are in at. Down and counting. So you have already heard from the curtain raiser that Voltmeter, and this is a number that I have actually read out of Voltmeter. So roughly today, up to today, we are about 12.8 million infected. We is the world we, so it encompasses the entire world. About 565,000 dead. Now, if you divide them by the numbers, so it's a bit more than 500,000 divided by 13 million, roughly speaking. So that's a very, very high mortality to infection ratio. Please note this particular part of the description that I'm saying here. When I say mortality to infection, this is a very important description that we need to focus, and I will come back to this again and again. Let's have a certain look at a few of the countries. Some of them have coped well, some haven't, and some are trying to. The United States of America, I stands for the number of infected, D stands for the number of dead, M.
Your presentation is off.
You mean from Google Meet?
Yes, yes.
Oops. Since when did this happen? Just now? Can you see it now?
Yes.
Yes.
Oh, right. I'm just trying to quickly check what are the other things that might actually have stopped again. So just to quickly check, Kishore, did you hear me until about 10-15 seconds ago, or was it off for a while?
Yeah, it's okay now.
Okay.
হ্যাঁ,
So very quickly to go back, so it's down
ফার্স্ট
and
ফ্লোরে এটা আমাদেরই বাড়ি, কিন্তু ফার্স্ট ফ্লোরে এটা তুই করতে হবে,
Please
Install
mute your
করতে হবে।
microphone.
ইনস্টল করতে হবে ফার্স্ট
Please
ফ্লোরে।
mute your microphone.
so it's the United States of America. I stands for 3.3
Okay, please proceed.
infected. D is
আর আরেকটা
130
লিখে নাও, আরেকটা লিখে নাও, বিটুইন পার্ক সার্কাস এন্ড মল্লিক বাজার।
and dead.
Amit, please
পার্ক
proceed.
সার্কাস এন্ড মল্লিক
Yeah, okay.
বাজার।
So MR stands for mortality ratio.
তুমি এখনো তৈরি করোনি? তাহলে কালকে পাবো তো,
If you
পাবো না নাকি?
divide D by the number of can I request the audience to
তুমি
mute
পরশু
the
দিনই
microphone?
দেবে, তুমি কালকে দেবে না দেখছি। ঠিক আছে, দেখি
Can all the participants please mute your mics?
ঠিক আছে। হ্যাঁ, তা নাহলে তো আমি তো
Mics?
হ্যাঁ।
Lipika
Amit, please
Atho,
proceed.
Lipika
Parak,
Atho,
your
please.
microphone is muted. Amit,
Lipika Atho, please mute your mic.
My microphone is muted.
কোথায়?
No. Okay.
হুম,
So everything's fine, Vishwata? Can you hear me now again?
Lipika Adjo, please mute your mic. Can you please mute your mic? Lipika Adjo,
Okay, so I will get started again.
thank you.
So
Okay,
it's
okay.
I'm first looking at the American statistics, a country that is suffering a lot at the moment. Hello? No? Oh,
We can see your presentation, Amit.
you can see or you cannot?
We can see.
But can you hear me?
Yes, we can hear you. Down and counting. In the right hand side, down and counting. In the left hand side, mathematical modeling of COVID-19. But
No,
please.
that's fine. But can you hear me? Can you hear me?
Yes, we can hear you. Please
Okay.
proceed.
Okay. Okay. So if at any point in time the audio stops, please just let me know. Please, because I am just looking at the full screen, so I wouldn't be able
Yes.
to look at the Google
Yes. And
screen.
can you
Just let me
please
know.
full screen? Can you please full screen mode? Can you please go to the full screen mode?
I am in the full screen mode now. Is it not in
The-
full screen?
No, we can see in the left hand side the PPT thing, all the slides, and then in right hand side only one slide.
Okay. Let me.
Now we can see you, not your presentation.
No, you should be able to see now. Is it the full screen now?
Full screen, but we are seeing you, not your presentation.
You see, not the presentation.
Now we can see your presentation. Slide. If you can go to the slideshow, I think. Kishore, please.
Is this better now? Can you see me?
See
Can
you.
you see the full screen now?
Yes, now it's perfect. Amit, perfect.
Okay, thank you. Thank you.
Amit, please.
Okay, so sorry for the many interruptions and the many breakdowns in between. Apologies. So we're down and counting, infected 12.8 million overall, all across the world. The number of dead is 565,000, and that's the Worldometer reading. More or less accurate, probably not exactly so, but we get the picture. The picture is grim. The American statistics, so I have randomly chosen a few countries, some of which are extremely serious in their conditions, some are coping well, some have already coped, gone beyond the peak point, and some are not yet at the peak point. The American statistics, so what I have done here is, for all these different countries, as you can see, America, then Brazil, where the issue is still raging, all I have done for MR, which stands for mortality ratio, I have basically divided the number of dead by the number of infected, because that is a very key number. The absolute values of the number of infected and the number of dead, they do not matter. What matters is how many people are dying out of infection, which also can be reverted to the information, how many people are effectively recovering from the infection. So that is very, very important. Now that number, and there is another aspect that I will shortly come to, the mortality ratio for the US is 4.15%. That for Brazil is 3.94, Russia 1.66, the United Kingdom, it's a deep red, 15.57, a very, very high number. So a lot of people who got infected actually died. Italy, 14.4%. Now, Italy, as we know, is basically in the cured mode, barring a possible second relapse. But basically, again, the number of people who got killed is very high, and you guys already overshot the Italy. Now, Hubei, more or less one of the central epicenters where everything got started, actually it got tamed at quite a low number, if the reports are to be believed, 6.6%. And now we come to India. Now, apparently, that might give us the impression that this is very good, because India is actually a lot lower than all the other countries that I have shown here, apart from Russia, 2.77%. It is not just good, it can potentially be very good if we are roughly restricted to that number. That is something that is unfortunately not probably happening in the immediate future, as I will show you later. But before we move out from this slide, please do have a look at the other descriptor that I have referenced, area. Now, if you divide the mortality ratio in percentage by the area, what you get is effectively how many people in percentage are dying out of infection in every square kilometer. Now, that is a very important descriptor as well. Why? Because we have heard so many different claims and counterclaims regarding tropical countries in the initial stage were declared safe. Countries with low population densities were declared safe. For example, countries in the Scandinavian countries, Sweden, in fact, and I will come back to that again later, Sweden did not impose a lockdown at all, because they assumed that the antibody would automatically develop and tame the disease. Unfortunately, this did not really happen that way. But more importantly, there are other issues that we see here, that this disease has not really spared any particular country. So whether hot or cold, tropical, subtropical, or even Scandinavian, or countries with sparse and heavy population densities, they all have been affected in varying proportions. Because, and this is something that actually accounts for what we call the herd immunity, and this is something that I will emphasize very soon. Herd immunity is like a balancing act. So while having a heavy population density can be negative, it can simultaneously be a positive if we are talking in the context of herd immunity. We will see that very soon. Now the outline, and I'm not entirely sure how much of that I would be able to cover because of the time lost. Part one, I will try to bring in herd immunity from a mathematical context. But before that, I will actually explain in very non-mathematical parallel what is herd immunity to start with. Because we have been hearing this word very often. Herd means a flock. Immunity is, for example, vaccination or something that protects your body from external pathogens. And there, in that particular context, I will bring in the mathematical part. Please note, this is the mathematical part, the model part, which does not yet involve any form of predictive modeling through artificial intelligence or otherwise. So this is conventional mathematical modeling, but that would give us the idea of what is it in the form of herd immunity that we want to see develop, and we want, or rather we hope and expect that it happens for our case in the different countries that we are at. The second part would be the predictive modeling part using artificial intelligence, that's AI, statistical modeling. And I will start with a biological outer layer. COVID-19, why is it dangerous? I will have a very brief foray into the biological description. So biology for a physicist, as you can guess. How does it look like? How does it propagate? Most of this information we have heard either for and against. I will try to put a logical paraphrasing around some of the things that we have heard and how much of that can logically make sense. Not everything, but some. Then we will go on to the mathematical model. Prediction. How India is faring as against the rest of the world. I've just shown you in the previous slide some tidbit examples of that, but then we will come across the real numbers. Infection propagation, shall we worry? And the mortality ratio. The mortality to infection, our prediction versus real data. And I will show you real numbers, not just plots. And those real numbers would actually foray into the future. We will see all of that. Now, part 3 is the mathematics of vaccine and drug preparation. Now that again might sound very much like an oxymoron, that mathematics and drug preparation are not exactly the same thing. I will go into this if I get the time, but the fact is I might not, and in that case we will preserve part 3 for the discussion section. I'm very happy to talk into the details. In fact, that is the talk that I very recently gave to literally higher secondary in the UK parlance, the A-level students. So all I did there was we actually discussed how the mathematics of vaccination, how mathematics can actually lead to paraphrasing or description of a vaccination, how it actually leads on to drugs. One of the raging words that you probably have heard is this, the last word, drug repurposing. So what does it mean and how does mathematics or physics for that purpose come into fray? Part 1, on to herd immunity. Now before we do that, let's clarify with some degree of understanding the 3 words that we have been hearing very often: epidemic, endemic, and pandemic. Epidemic. Imagine we are talking about an infection within a certain specified area. The infection and its implication might be dangerous, might be very bad, but we are restricted to the geographical area. A classic example is that of cholera. Now, Indians would know this very well because this had been in the past a very, very destructive form of an infection. But then again, it unless you really physically migrated from one particular region to the other one, it was largely limited to the origin or the place around its origin. The next bit was endemic. That's like one step up, and this is what you see from the color coding that I have used. A fast-growing local epidemic. 60% of the European population died out of Black Death. This was some time ago, but the Europeans would know very much about that. So this is a very bad form of infection that is now migrating to pandemic. Now this is the worst form. So an epidemic with a passport is the popular way of describing it. P stands basically for a passport. So an epidemic that does not abide any geographical boundary. Now, to understand the fundamental difference, you see, epidemic is something where you had the description of a particular locality. Endemic is something where you had a propagation along a certain track. In the case of a Black Death, the propagation happened along the Silk Route. For pandemic, it is not following any particular path. It is sort of homogeneously and isotronically moving across all continents and subcontinents. Its impact is first. So I'll come back to this video in a second, but before we do, let's just have a look at how the COVID-19 molecule looks like. I have taken the liberty of picking and choosing materials from the internet and some from the COVID-19 official website. So the virus, it looks like a tennis ball with a few spikes in its outer layer. So the tennis ball, if you cut open the tennis ball, you see a tangled greenish mesh inside. That is the RNA, the ribonucleic acid, the principal culprit behind its propagation. So if the RNA basically manages to enter your body, then that's when the infection actually starts. And the outer layer is the lipid membrane. And the spikes are very interesting things. These are called the spike proteins. The spike protein, for a physicist, it is much like an indicator, a threshold level, a threshold measure that tells you that you have got an infection or you haven't got an infection, and if you have got an infection, at what level it is at. Now, just to give you an insight into why spike proteins are so very important in this particular context, and why, and this is a very dark news that I'm sharing, I personally don't think that there's any vaccine in the horizon in the immediate future, not in India, not in any country, notwithstanding the claims and the counterclaims. It's simply because this COVID-19, who declared number of traits, that means the number of different forms of COVID-19 are more than 100, and in certain other, for example, in Houston, in Johns Hopkins, the claim is more than 300, whichever one you like to believe. So that means this particular disease comes before you with 100 to 300 different faces. Now, if you have your mechanism of identifying one particular face, that mechanism is your antibody, that can identify your face 1, but then it is lost for the other 99 or 299 faces. So that means it cannot form the chemical bonds, or cannot basically catch up with that particular pathogen, and hence it is extremely difficult. So the spike protein here plays a hide and seek game, and that's why COVID-19, or for that purpose, most viral diseases are extremely difficult to track. It is for the same reason we haven't got a vaccine for Ebola. We have got buffers like remdesivir. We haven't got a vaccine for Ebola. We haven't even got a vaccine for Zika virus 1952. So we should be very cautious in our expectations, and we should not go overboard when we hear people saying that there have been some new magic. Now, the next bit is the size. That's important. Now, compare the COVID-19 size. It's about 0.08 of a micron to 0.14 of a micron. Micron is 10 to the minus 6 meters, as we all know. And compare that against influenza, which is almost like 100 times bigger. Now, what is the implication of that? It's very simple. Imagine that I'm spraying bullets, some small bullets and some heavy footballs. I'm spraying them with the same power. Evidently, the smaller bullets will propagate longer, and the larger footballs will drop short, right? This is exactly what is happening when we are sneezing or when we are coughing. So what happens is COVID-19 literally, physically can propagate through a much longer distance than the influenza, and hence all those rules about 1 meter and 2 meters. If you ask me very honestly, is there a justification in basically keeping 2 individuals at least at a distance of 2 meters? Why is it 2, not 1.5, not 3, not 2.5? There is no clear quantitative answer to that, but 2 is sort of taken as a rough, safe distance. It's a very simple fluid mechanical calculation that you can do, and you will find that 2 meter is roughly when it basically dissipates most of its energy, so it would fall a bit short than that. So that's why it's safe. All of these from the COVID data portal, and the later analysis that we will show is largely due to the Johns Hopkins data repository, but that is not the only repository that we have accessed. We've used others. So I am sharing with you a video. So this is the video that the European Center for Disease Prevention and Control has come up with, and that video gives you a few signatures of how the disease started. I do not intend to implicate any particular country or race. All that I'm trying to portray here is certain symptoms and certain ways that the disease got started out with. Coughs. The scans clearly reveal patches on the lungs. Please note, I'll come to that in a few seconds. Breathlessness. Asymptomatic propagation. People are being scanned to try and find traces of the disease. So people are trying to find the trace, one of those 300 that I have just mentioned. And this is sort of the suggested defense. Hand washing, typically 20 seconds. Sanitizing with alcohol 70% and above by at least 5 to 6 seconds. I will come back to these numbers in the course of time. And this is green notification. It is helping you a little bit, but it is not taming the disease. And typically the gestation period is 14 days. So I'll stop this video right here, and we will go on to the next slide from this. I've just shown you in the video certain symptoms: high fever, cough, breathlessness. Problem is, all of these also happen for simple flu. So do we have a simple flu? Well, that is a good strong check, but then you come to the gestation period. So if you still have all those symptoms, and probably even exacerbated versions of those, beyond the first 10 days, typically 2 weeks, then you very likely have got an infection of a very bad form. That may be COVID, which is more likely in the present situation, maybe something else, but it is very unlikely to be a normal flu. Now, what are the more technical detection mechanisms, what is it that we actually see? ARDS, it's an abbreviation standing for Acute Respiratory Distress Syndrome. So very bad form of breathlessness. That then moves on to what we call progressive hypoxia. Hypoxia means lack of oxygen in your blood. Why is oxygen important? I think we know that because oxygen is basically that ingredient that supplies the energy traffic all throughout our body. And eventually the lack of oxygen leads to multi-organ failure. We'll come just to a little bit more biological detail after this. What have been the suggested therapeutics? Now here, I wanted to share my personal, not just my personal view. These are views supported by a whole range of different publications from Lancet, New England Journal of Medicine, and a whole range of others, BMJ, etc., Nature Science. We have heard patients complaining a lot, initially we all did, that we are not having sufficient number of ventilators. Question is this really needed? The point is, under saturation, which is of oxygen in blood, is a destructive thing, as I've just mentioned, with the name of hypoxia. But oversaturation of oxygen is extremely dangerous as well. So ventilation is probably very often more harmful than otherwise. Nebulization is probably a lot better because it is controlled oxidation. The next bit is, in emergency situation, if it is possible, if you have access to a hyperbaric chamber at 100% oxygen where it's not being pumped into your system, but you're being surrounded by it, so that the body is allowed to sort of diffuse in, then it is probably a lot better option. And if that is not an option, blood transfusion with normal oxygenated blood that comes up with the sufficient number of hemoglobin, which then connects with the MEMS and converts the, basically carries the oxygen onto the lungs, is what is needed. And I will come back to this in a second. In terms of drugs, 3 candidates have been thrown in the fray. Initially, a huge amount of reaction from the Western world. Hydroxychloroquine was initially suggested in Cuba and India, and with a claimed good bit of success. And later, when it came out to be from the Western world, including in America, America initially supported them, then withdrew, then came back in the frame. UK, along with Europe, they did not like the idea of hydroxychloroquine because there was this conventional psychological buffer. How come an antibacterial drug be good enough for an antiviral mechanism? Well, it's way beyond that, as I will try to show you with some bit of description. Azithromycin, so that's an antibiotic. Corticosteroids, that's another group. So all of them basically connive to inhibit the viral growth and replicate the chemokinetic pathway blocker. Why is this COVID-19 so very dangerous, even compared to its immediate predecessor, the SARS-CoV-1? The 2002 and then later the 2012 candidate. Well, let's see how it actually works. The red blood cells, they contain a certain protein. We all know this. It's called hemoglobin. Now, what we may or may not know, this hemoglobin has 4 MEMS. Now, these HEMs are, as you can see in the right-hand picture, the one that I have just shown you. So this is like a tangled bunch of small dumbbells all connected with each other. And each HEM contains or carries with it 1 active iron ion. And that iron ion is a dangerous thing to happen because that might actually cause massive negative havoc in your body. So the iron ion is caged in another chemical, the chemical name is porphyrin, and it can bind with 1 oxygen molecule when it's released. So basically, you are carrying a bag of, and the bag has 1 iron ion, which should or should not be caged, uncaged, depending on the situation. Now, alveoli are the names of the small lung sacs. So if you think of your lungs, the lung is lined with a lot of small sacs. The sacs can actually expand and contract because there is certain fluid inside. When we have a lung situation, that can be due to COVID, that can be due to other reasons, the fluid inside the sac, the alveolus, actually dies, and the alveoli lose their power of expansion and contraction. So then what happens is the elastic property gets lost. If the elastic property gets lost, you have a lung which is basically frozen like, it's petrified like a stone. So the lung doesn't work. If the lung doesn't work, we have a multi-organ failure. So basically the way this COVID works is COVID has a strong glycoprotein. So glycoprotein is the name of a certain type of protein which is carbohydrate activated. So the glycoprotein comes as a shield and it cuts that cage, that porphyrin cage, and sets the iron ion free. Now iron ion, when it gets free, it does not do, so it travels to every other part of the body and it does not just come into interaction with the oxygen, the O2. So due to the lack of oxygen bonding, basically COVID-19 effectively eats up the hemoglobin. It's just a popular parlance. It simply goes to say that the iron oxygen bonding is not being formed. If it is not being formed, then what happens is the oxidative iron ion from the heme hit the epithelial layer in alveoli, which then gets damaged, and eventually it becomes petrified. In more medical parlance, you will call it iron homeostasis. And that leads to the lung damage. Now, I'll show you a picture after this, which will show you the form of lung damage, exactly what the doctor sees in front of them. The body compensates for this lack of oxygen carrying capacity and delivers by having the kidney release or ultra release a certain hormone, erythropoietin, which tries to sort of substitute the lack of the dead alveoli. So it tries to redo the job of the alveoli. It can't, and then your kidney is damaged. So initially, the lung damage sparks the kidney damage, and eventually the body just collapses. Now, hydroxychloroquine, azithromycin, and corticosteroids, they basically work in the following way. So hydroxychloroquine, it stops the glycoprotein, at least partially it stops the glycoprotein from it cutting the iron cage free. So that's it. So it's like a pathway blocker. It's a chemo blocker. And that's how it actually functions. It is exactly the same way it works for malaria, which is what this drug was initially for. Malarial drug was chloroquine. Hydroxychloroquine is, you may call it a more potent version of the conventional chloroquine. Azithromycin does a similar sort of job together with the corticosteroids. I'm not going into those bit of details. Those are partly reserved for part 3 if we get the time for that. So this slide hopefully gives you an idea of what COVID-19 does in the form of a damage. So COVID-19 eats up the hemoglobin and it basically does not allow oxygen to be doing its job. So the oxygen supply is stopped and hence we die. Now this is, as I just promised, this is from a picture. So this is a publication in European Respiratory Journal. So it's a scanned picture, as you can see. If you look at the patches here, the patches are where these released iron basically has wreaked havoc within the lung structure, epithelial layer. So the epithelial layer is badly damaged. As you can see, these are the damaged patches. And eventually, as I said, I mean, it will initially lead to lung failure and then to kidney failure and multi-organ failure.
Does it mean that someone can be infected with the virus and still not show symptoms at all? And if that is the...
Sorry, I can't hear you. The sound got a bit tangled up. Can you repeat, please?
If anybody has question, please.
Sorry. If there's any question,
We will have a question and answer session afterwards.
I'm happy to take an immediate question.
We can take
but, the structure is not particularly conducive. So if you want to have me take the question, if there's just one question, we can take it immediately. Or shall I move on? You can repeat the question.
I think her connection is not good, so
Right. Okay. So I
please
just move
proceed.
on for now, and I should be
one thing we should mention that if anybody want to ask a question, please write in chat box. Okay.
That's a very good suggestion, I think. Excellent suggestion, because then I can actually look at the chat box with some help from Kishore later, and we can take one question in the order that they have been asked. Or back then we can even do a little bit of discussion. So just moving on to the next bit. Now, WHO, the World Health Organization, in its curious stance in this particular case, pandemic and then no pandemic and then eventually a pandemic, hydroxychloroquine bad, then good, and then very good, corticosteroids not so good, and then now probably good. All these quixotic statements, self-conflicting and contradictory statements, now they have coined a new word. They're calling it infodemic. Now, this is one of the parlance that I personally agree with. Now, infodemic actually alludes to a certain description of lots of WhatsApp University, Facebook Research Institute generated statements that there are certain magical cures. If you follow them, you're completely immune. I'll just randomly take a few of them. Lemon or vitamin C. I'm pretty sure that many of you have started out with vitamin C, which you probably or might not have done in your entire life, but suddenly you saw that vitamin C can be a good buffer. Well, it can be a very good buffer. It will not do a magic in the space of a couple of weeks. It will work for you. It's like a protective shield for you if you have been using it for the last couple of years. Not miraculously new. And why so? Let me read out the first sentence. The body regulates the pH. Now, just to remind ourselves of what the pH is all about, pH typically 0 to 7 is for acids. pH 0 is the strongest form of an acid, so like very strong hydrochloric acid, etc. And anything exactly sitting at 7, that's water. 8 to 7 plus going up to 14, that's alkali. So the strongest form of alkali would be hitting the margin 13 and 14, and the strongest forms of acid are sitting at 0 and 1. Just to give you an idea of what we are talking about here. Now, the SARS-CoV-2, the more formal name for COVID-19, has a pH range between 5.5 to 8.5. Now, please note what I have just said here. 5.5 is still within the acidic range, and 8.5 is just inside the alkaline domain. So it's extremely dodgy. See, the problem here is it's neither typically acidic and it's neither typically alkaline, it's somewhere in between, and that's a problem. Because when I start drinking my lemon juice, what does the body do? The body tries to recalibrate the additional intake of vitamin C within its expected range of 7.37 to 7.43. Outside, anything less than anything more is extremely dangerous to the body. There are medical doctors who can give you more details. I would happily give you more details because these are not so very difficult to understand. But let's take it for granted for now that that is the pH range on which the body operates normally, 7.37 to 7.43. Now, suddenly, if you dump yourself a jug of lemon juice, it will spike it, maybe let's say, to something close to 3 or 4. But then again, the body will equilibrate very fast and try to maintain that equilibrium. Okay, so it wouldn't do anything magical. Now, stomach, and this is how the whole thing works, has a pH between this particular range, so typically strongly acidic, and this will try and tame it down. So the proton pump will ensure that the body maintains this pH within the range that I've just mentioned, 7.37 to 7.43. Now, the bicarbonate of soda, is that of any use? Now, that might be a completely different prescription. It's pretty close to the upper end of the pH, is pretty close to the upper end of COVID-19 pH. So effectively, you can, it is not particularly good for you to be drinking the bicarbonates of soda. That will not be particularly helpful. But in terms of killing it, it can. For example, if I purify certain vegetables with soda water, by soda water, I do not mean the cold drinks. By soda water, I simply mean bicarbonate of soda, so cooking soda with a bit of water. So that might be used as a defense. So that will probably work. This is something under study, and that's why I'm carefully using the word probably. But in most of the experiments that have been done with this, it has been seen to tame the virus. Now, having said that, what I'm not suggesting is external green vegetables or other forms of food that you're buying from the market, they have to be purified in that particular way. That is probably sort of auto-purified. One of those typical open questions that we haven't really got an answer for. We have got some statistics. I will show you some statistics, but we do not really know why is it going that way. There are some conjectures, but conjectures are not proofs. How does it propagate? P2P, person to person. So an infected person infects another person. That another person who was not initially infected but is prone to infection, we will call them susceptible in the description henceforth. This is an airborne disease, very likely. So I have given you some journal references here. There are loads of them. Now, mark the word here. Now, if it is seriously airborne, social distancing actually could be useless. Now, this is something very, this is also being counterclaimed. So the claim is from not just from that particular Chinese group. It's a PNAS publication. It's one of the most vaunted publications in biological and mathematical sciences. But at the same, and there are other supporting publications, but there have been counterclaims as well. The social distancing may or may not be useful or may not be useless if it is completely airborne. Given the indications, and I will show you in the next few slides here, that it is at least partially useful, but it might not be completely useful. I mean, the distancing part. So masking is important. The COVID propagates by surface transmission. Now, this is a very new claim. Does it? Well, this particular Lancet publication claims that this is a case of a false negative. Its claim is it doesn't. Now, given the recent precedents of publications coming out of Lancet and NEJM, we should be rather careful about what to take and what not to. Now, here are some statistics that I was alluding to just a few minutes ago. This virus is known to stay safely between 4 to 13 hours in different forms of metals. I'm talking about coppers to steel. Glass, somewhere in between a couple of hours. Cardboard, almost a day. Plastic, couple of days. Clothes, 16 hours. Now, these are all alarming statistics. They would say, my God, I will just die to anything that I touch or anything that I wear. Well, not really. There's something called a half-life and a quarter life. So basically, the ones that I have written down here, 24 hours, 2 to 3 days, 4 to 13 hours, they're talking about the entire lifespan. But the half-life and the quarter lives are much, much, much shorter than those. So basically, with all of those, you are absolutely fine. Now, people did some sort of similar experiments. Now, similar has to be taken with a pinch of salt. They studied some lab aerosols, and this particular statement actually connects to the airborne propagation as well. They studied how the lab aerosols could be spread and how far they actually travel. Problem is, the lab aerosols that were devised were not exactly in the same order of magnitude, size-wise, as that of COVID-19, which as I have shown and discussed, it's typically 0.08 to 0.14 micron in size. Now, these were much larger than that. So basically, these were much smaller than that. So these naturally traveled a much longer distance than what the COVID-19 in reality does. So the first statement about social distancing being useless, that might be a tall claim, which is not exactly driven by description. But research is ongoing on this particular one. What is definitely true is it is partially airborne. As of surface transmission, it is almost definitely not true.